All right, China's rapid economic development has led to an exponentially growing demand for energy, and in China generates more than two-thirds of its energy by burning coal. During the period of 2000 to 2012, China's coal consumption increased at an average of 8% per year, and the 2012 consumption was about 3.8 billion tons of coal. Use this to predict China's coal consumption. Okay, so let's kind of think about what information we're given and which of our three equations we want. We're actually given a rate. We're given that it grows at 8%. That's 0.08 when we actually use that in the formula. So we want to use the first of those three formulas, the Q equals Q naught 1 plus R raised to the T power. So we're going to go ahead and treat time 0 at 3.8 billion. So we're treating that to be 2012. Okay. So Q equals 3.8, 1 plus 0.08, so 1.08, and then raised to the T power. Well, if we're treating 2012 as year 0, then 2020 minus 2012 is 8. So we're going to raise that to the 8th power. Okay, so let's go to the calculator and type that in. So 1.08 raised to the 8th power, and then I want to multiply that by 3.8. Okay, so I get 7.03. So about 7 billion tons of coal. 7 billion tons of coal. Yay. All right. Second part, make a graph projecting China's coal consumption through 2050, and then talk about the validity of this model. All right, so let's kind of go through how we want to do this. We need a couple of points. So we've got 0, and the amount at time 0 is 3.8. And then I need doubling time. So how long does it take for it to actually double? Well, we need to go back and use another formula. We actually weren't given that information. Our growth rate was about 8%, so we can actually use our estimating formula. So our time to double, that rule of 70, would be 70 over P. So in this case it's 70 over 8. The 8%. And so 70 divided by 8 is about 8.75, so that's about 9. Okay, so it takes 9 years for it to double. So in 9 years, we're going to have 2 times 3.8. So 2 times 3.8, which is 7.6. Okay, and then we'll do, let's see, 2 times the doubling amount, so 18. And then I want to double the 7.6. So 2 times 7.6 is 15.2. And then we want to add more to that. So 3 times the doubling amount puts us at 27. So I want to double that 15.2. Let's see, 15.2 is actually 30.4. And then, let's see, how far are we going with this? 2050. So 2050 minus 2012 is about 38. So I can keep going. So I'm going to do another 9, puts us at 36. And I want to double that, so that's 60.8. Okay, so I can draw a pretty good graph with this. So here's 0, 9, 18, 27, 36, and let's see, looking up at these numbers, I'm going to count by 10. So 10, 20, 30, 40, 50, 60. Okay, so 0, 3.8, right about there. 9, 7.6. So right there. 18, about 15.2. So right there. 27, 30.4. Right there. And then 36 and 60. Okay, so the graph, oh, missed a point, but hopefully you get the idea. A little more of a curve there. So our graph of this consumption looks just like that. Consider an antibiotic that has a half-life in the bloodstream of 12 hours. A 10 milligram injection of the antibiotic is given at 1 p.m. How much antibiotic remains in the blood at 9 p.m.? Draw a graph that shows this amount of the antibiotic remaining in the drug estimated at that time. Okay, I got a couple of different questions to answer here about this. So let's start with what our initial amount is. So our starting amount is 10 milligrams. So we'll just remember that it's milligrams, so we'll never see that. And they told us that the time for half-life is 12 hours. Okay, so that means we're going to use the half-life formula. So Q equals 10 times 1/2 T divided by 12. Okay, so at 9 p.m., so 9 minus the 1 is 8. So the amount at the bloodstream after 8 hours is 10 times 1/2 to the 8 divided by 12. Okay. Okay, so let me try typing that in the calculator. So parentheses 1 divided by 2, and I'm going to raise that to the 8 divided by 12 power, and close that, parentheses. Okay, so I get that number there, and then times 10. So about 6.3 milligrams remaining. Then we're asked to draw a graph of some kind. So let's kind of list out our ordered pairs. We have 0, 10. It said it took 12 hours for half of that, so at 12 hours we're half of 10, which is 5. Another 12 hours, so at 24 we're at half of that, so that's 5 halves or 2.5. Another 12, we're at 36. Whoops. 36, and we're at half of the 2.5, so that's 5 divided by 4. Let's see, 5 divided by 4 is 1.25. And I think we're good. Okay, so 0, 12, 24, and 36. So I'm going to start off at 10. So I'm going to count by 2s. I'm just picking a number here, 2, 4, 6, 8, 10. Since I'm sketching this by hand, I'm not too stressed about it. It's a little on the sloppy side. So 0, 10, 12, we're at 5. Let's see, then we're at 2.5 for 24. And we're at 1.25 for 36. So you can kind of sketch that in that way.